Well, I think 3, 2, 1, 0. We're live. We got live images on the homepage. Good evening. I probably shouldn't say good evening, should I? Because I'm in England and it's midnight here. But I know we've got people from Australia, New Zealand, America, Japan tonight, India as well. So welcome to all of you. I'm Paul Cox. This is Slooh Space Camera. In fact, I better show you who I am, really. Sorry, I forgot to switch over my webcam. So good evening, everybody, and welcome to the live universe. And immediately we can see on the screen a fantastic image of a comet. So listen, I have to go through the normal housekeeping stuff. You need to be looking at this on the Slooh homepage. You can view it on YouTube Live. You can view it in the Google Hangout. But if you view it on the homepage, which I'll share for you, because I know some people only can watch on mobile, so they can't look at the homepage. But if you look at the homepage, you get to control which telescope you're looking through. So I'm going to share the screen very quickly so that you can actually see how to do that. And just as I did that, of course, the image of the large comet disappeared. Let's have a look what we've got. Everything in this round blue window on the home page, that's our live images. We're using 3 telescopes tonight and 1 camera. Well, we've got 4 cameras, but 1 camera in particular. This is half-meter telescope. Now, we should be seeing some of the faint and fuzzy comets in there, but probably our best bet tonight is going to be our T2 high mag telescope. And there we go. Wow. Actually, sorry, I hadn't actually seen any of these images tonight because I've been getting ready for the show, but that is Comet 168P Hergenrother, which is the real one that we're talking about tonight, because it's brightened so much, and it's brightened to me since yesterday. Now, just to warn you, some of the we have got a little bit of high cloud today at the observatory, so if you see a funny colour come over the image, that's because a cloud has gone over it. So anyway, that's the second telescope that we're using, and that's Comet Hergenrother, which is unexpectedly brightened. Let's have a look at the next one. And this is our T2 wide field, and there you can see it in the context of the surrounding star field. So just right of center, what looks like a fuzzy star with more fuzz on one side than the other, that's the actual comet. So comet's made up, if we just hop back to the T2 high mag, you just press these little arrows on the home page, and it'll take you from one view to another. Oh, now this is taking us to another comet, which I can't see in that particular view. It's probably a good time for me to take you through the list of comets that we're going to be looking at, because I'm going to be talking to you, so I can't really concentrate on the images. So you keep your eyes open on those. We've already seen a couple of nice ones. But anyway, on the half-meter telescope, we have got, we saw Hergenrother just as it started up. We've then got Comet 262P McNaught-Russell. Don't get too worried about the names and the numbers and stuff like that. We'll deal with those another time. But just to remind you that if a comet has a P in its name, like that, 262P, it means it's a periodic comet. It means that it orbits the sun in a kind of 200 years or less, and we predict that it comes back. Now, a non-periodic comet, like the one that's going to be on the half-meter telescope at 10 past the hour, so in 5 minutes' time, that is C 2012 J1 Catalina. So all that tells you is the C says that it's a non-periodic comet, and that doesn't mean it's not going to orbit the sun again. It just means it's going to orbit the sun with a very long period of time. The 2012 tells you when it was discovered, and the J1 tells you actually the month and the order in which month a comet was found. And then in the brackets there's always the name of the discoverers. So in that one it's Catalina, which is the Catalina Sky Survey. And then at 20 past the hour, in the half meter, we've got Comet 260P, so another periodic McNaught. And those of you who have watched our shows over the years will know that McNaught is one of the guys working at the Siding Springs Observatory, good friend of ours, and that's actually linked to the Catalina Sky Survey. Now, on the half meter telescope, so we've got, right, 3 comets that are going to appear in that half meter view. Now, I can't see this one because it's a little bit faint in the half meter view at the moment, but keep your eyes open when the image changes to color. Let's take a quick look at T2 High Mag. Now in T2 High Mag, we already saw Hergenrother. That was there at the start when the show started. Then 2 minutes past, which should be this one actually, is 262P McNaught-Russell. So maybe the coordinates are wrong on this one. Maybe we've missed that one, but we'll judge it later when we see all of the images. At 7 minutes past the hour, we got Comet 2010 S1 Linear. That's not to be mistaken for the S1 Comet 2012, which is this big one that's going to put on, hopefully, cross fingers, this great show for us next year. Then at 12 minutes past the hour, it's that Catalina one. And then at 17 minutes past the hour, it's going to be Hergenrother again. So you can see there that we've got double the number in the T2 High Mag and T2 Wide Field telescope than we have the half meter. So keep checking back on the T2 High Mag more often. But anyway, listen, why are we looking at this tonight? Well, I kind of timed it badly. I should have been talking about this now when Comet Hergenrother was up, but I've got a little image that I'll show you. This is a pair of images, and these are not live. We don't normally show kind of non-live images, but these two images are of the same comet, Hergenrother, taken by Slooh member Nermal Paul. And on the right here, in fact, I'll zoom into it a little bit, so you have to look in the Hangout now. This side, on the right-hand side, is Comet Hergenrother on the 19th of September. So what's that? Just 10 days ago. But on the left, this was taken last night. Now look how much it's brightened. And don't forget, Comet's made up of two main things, really. They're made up of the coma, which is the kind of tight ball of fuzz which is around the nucleus, and then of course you have the tails, sometimes one, sometimes two. It can be more than two actually, and notice also actually in these two images that the tail is pointing in a slightly different direction. That's because it's always pointing away from the sun, so you can see that it's changed in its orbit. But anyway, that's what's prompted this show, and people enjoyed the last comet show that we did when we chased down these other comets, and these are slightly different ones tonight, or some of them are. So keep looking. I still cannot see which one was this. This was 262P. So I think maybe the coordinates are wrong on that because it's not showing up in any of the telescopes. But the T2, oh no, look, we got one in T2 High Mag now. So there we go. What's the time now? 7 minutes past. I should post this so you lot can kind of keep an eye on it. This is 2010 S1 Linear that's coming on, I believe. Anyway, you keep your eyes on that, because I'm going to concentrate on making sure that the Hangout keeps running and everything runs according to plan. But anyway, this is by the way, I forgot to tell you, there's a Pinterest button on the homepage, and I must also increase the magnification for people who can't watch it on the homepage. So there you go. I'll increase the size of that. Oh, if you've got a Pinterest account, if you hit Pinterest, the Pinterest button on the homepage, it'll automatically take a snap and post it to your Pinterest board. So do keep an eye open for that. We need your support with all of this lot. I'll tell you why right at the very end, actually, because it's pertinent to what I'm going to talk about tonight. But you can either do that, give us some support through the slooh.com/MySky campaign, or just through a Slooh membership where you can control the telescopes that I'm using tonight and members are using all night tonight to image these comets. So anyway, tonight's show, back by popular request, we're going to chase down these 5 comets. We've already seen, this is the second one we've seen already, but it also includes Hergenrother, which we're going to see again at the end of the show. And we covered that because it brightened, but 2 days ago there was a further report. In fact, I only spotted the report after I'd spotted how bright it had got. I was actually doing some testing on one of the telescopes manually at dawn, and I decided to use Hergenrother as an example, and suddenly I saw this really, really bright comet, and I even had to check to make sure that I had selected the correct comet, because it was just so much brighter, and you saw those comparison images just then. So that's what kind of prompted me to do this, and a few people did email me to say, hey Paul, love the comet show, can we do another one please? And don't forget, you can always email me, coxy@slooh.com, coxy@slooh.com. I'm happy to hear about anything, but also if you've got requests or ideas for these shows, then just drop me a line. So what we're interested in is Hergenrother and why why should it have brightened? And don't forget, this is now the second time in a 3-week period where it's brightened and then dimmed again, brightened and dimmed again. So we know that something's happening physically to this comet because the sun didn't get any hotter. Obviously, the comet gets closer to the sun, so the outgassing does increase, but not in the way that we've seen it, going up and down, kind of on this roller coaster ride. So one possibility is that it's kind of crumbling and falling apart. And when an object does that, when a comet does that, it kind of exposes more surface area. And we kind of all remember from high school biology, elephants and mice, and how much volume to surface area and all that kind of stuff, isn't it? I forgot it now. God, that's a long time ago. Anyway, you know what it's like. It increases the surface area, so it can outgas more and produce more coma, more tail, more everything. So we're going to have a look at that again in a little bit. But of course, that's not the only comet that we've looked at over the last couple of weeks, because you've probably all read, I mean, anybody who's here is interested probably either in passing in science and astronomy or is really into this kind of stuff. And a lot of us are really into it. We're really passionate about it. We really love doing this stuff. But you may have seen this. Some of the newspapers have blown it up out of all proportion, and a couple of us have been laughing because with each new report of it on the web or in newspapers, this thing's doubling in size, doubling in brightness, doubling in how, or halving how close it's going to go to the sun and stuff like this. This is this comet called 2012 S1. And what they're predicting is that in November, December 2013, next year, so a year away, some of the predictions are saying this is going to be a once-in-a-lifetime comet. So, it could be, its tails could be filling the skies. So we got to cross fingers for that, because it could be absolutely spectacular. And actually, talking of spectacular, some of the comets that we're going to be observing tonight, they're not visually spectacular in the same way that the galaxies and nebulae that we've been looking at in these nightly shows in this month of live astronomy. We've seen some marvelous objects, haven't we? We've seen the Andromeda Galaxy, the Triangulum Galaxy, the Lagoon Nebula, the Trapezium Galaxy, all of these gorgeous, beautiful, bright objects. Remember the Orion Nebula when we did that late show because it was rising late in the morning? Well, these comets, they're not as spectacular as that, are they? But I think that actually, in a way, they're far, far more interesting. And it's been like that forever. Comets have always been something that have been a transient body in the night sky that have been visible with the naked eye. Now, these ones that we're viewing tonight, these are not visible with the naked eye, not yet. They're not bright enough, so they're only visible through this kind of telescope. And I'll just flick through some of the other views, see if we've got anything in the half meter yet. No, still nothing in the half meter. There is one fuzzy patch, but I wouldn't bet my house on that one. But we've definitely got, this is the third one now coming into T2 high mag. So there's another one, and we can probably see that in the wide field too. I can't see it in that image. That might come through in a sec. So do keep flicking through those when you're on the home page. Check out these different feeds to see, where these comets are coming from. But anyway, what I was saying, comets have kind of been this source of wonder and amazement for human beings, probably since we started walking and talking and being able to say, wow, and pointing in the sky. So it's been this kind of objects of mysticism for millennia. And I talked about the predictions, didn't I, about this comet for next year. But those predictions are based on science and observation of that comet. But think back to the time when kind of the stars and planets were used to predict the future. And the sudden appearance of these kind of ghostly visitors, that they were seen as omens and harbingers of doom and gloom. And, I'm sure a lot of them were seen as impending calamity. But they also kind of captivated us as well, and they caught our imagination. But, part of the prediction thing, most kings and leaders of countries, for many thousands of years now, have kind of had their professional pet astronomer next to them, to tell them and predict of these bright things, to predict eclipses and stuff like that. And most of the time, if they got it wrong, they'd lose their head. So it was a pretty good justification or motivation for kind of observing well. But these kings and world leaders, that they would actually take sightings of comets as omens. And wasn't it, didn't I read? It was Genghis Khan, wasn't it? Genghis Khan apparently saw a bright comet and took that as a sign. He wasn't a religious man. He did take advice, I think, from various religions, monks and priests, but I don't think he was actually religious. But he took this bright comet as a sign that he should go to battle and conquer Eurasia. So it's not everybody saw them as doom and gloom. Some saw them as, positive omens and messages and signs that they should go off and do something, fulfill their destiny. And I guess if Genghis Khan's experience is anything to go by, then maybe there was something in it. I mean, you know me, I'm tongue-in-cheek about that. You know that I don't believe in that kind of hokum. So when did our view and opinion of comets change? When did they stop becoming these omens and harbingers of doom, and become something that we understood, and knew that there's no superstition involved with them. They don't change anything except the night sky occasionally. Some people would argue probably that they're no less mysterious and beguiling than they've ever been. And actually, I've got a good example of that at the end of the show, which is kind of a bit sad. But, so when did it all change? Well, I read something a couple of weeks ago that was new for me. I've been doing a lot of reading lately, and this particular one was about Sir Isaac Newton and him and his laws of universal gravity. And one thing that I didn't realize, I'd always known, I think all of us knew, that the story of the apple falling on his head is a bit of a myth, and that's kind of gravity, what made that fall to Earth and stuff. But what I was reading a couple of weeks ago was actually saying that it was actually a comet that seemed to be the start of his work with gravity. And he saw, saying that Newton discovered universal gravity is wrong, isn't it? So I don't know the phrase, but it was him really generating and creating that law of universal gravity. And it was apparently prompted by his observation of a comet in 1680. And it was November 1680, and he was in Cambridge in England, and he observed visually this bright comet. Now, I don't know how, it didn't say in the book that I was reading, but he also discovered that the same comet had been observed in Boston, New England. So it had been observed on both sides of the channel. And what relevance that has, I wasn't too sure. It didn't make it that clear. But anyway, what happened was that the comet, as they do, disappeared behind the sun. Now, we know why they disappeared behind the sun. But they saw, even in the 17th century, a comet heading towards the sun, disappearing into sunlight in daytime, and then assuming that it just carried on going. Don't forget, they believed that, the universe was a perfect, everything was perfect in it. Everything beyond the moon they thought was perfect spheres, perfect orbit, perfect circles, stuff like that. And they believed that these comets just kind of went shooting straight on. But here's the thing that changed for Newton. A month later, a new comet appeared, but guess where it appeared from? Behind the sun. It looked different in appearance to the comet that had disappeared behind the sun, but this new comet was then visible from December through till March in 1681. And he apparently asked the question, which is so obvious to us now, isn't it? But he asked himself the question, was that one comet or two? In other words, was it one comet orbiting the sun, or was it two comets, one going in one direction and another one just by chance coming the other way? I'm just going to flick through the telescope fees just to make sure I'm not missing anything great. Oh, look at the T2 wide field telescope. That is a gorgeous, gorgeous comet. And I can tell I'm already running behind. So these views will continue to about 25 past. And there's a nice 1.5 meter. You guys keep an eye on that, because I've got to finish this story for you. Otherwise, none of it will make sense. Anyway, Newton drew up this diagram of his and other people's observations of this comet that they'd seen. And it became very clear from those observations, those timed and dated observations, that it was a single comet. Looking at the diagram, he knew that there must be some unseen force which was acting on this comet to make it change direction so much. Don't forget, a lot of comets have this kind of parabolic orbit, which means that, you know, they're fairly straight until they get fairly close to the sun, but then they slingshot really tight around the sun and then come back again. Look at the T2 high mag telescopes just come into color. That's a beautiful image of that. I'll tell you what I'm going to do. I'm sorry for running over. I'm going to change this. I'm going to add on an extra 5 minutes so that you've got live views for another 5 minutes. It might go into different objects, but at least you'll have something to look at while my drone's going on. Anyway, he continued. That really prompted him, and that gave him this idea of gravity, the force of gravity, and he then continued to work on that from I think it was 1681 through to 1684 when he formed this law of universal gravity. Now, Newton knew Edmund Halley. Now, some of you will know the name. You might not know who he was, but he lived from mid-17th century through to mid-18th century. A lot of these guys did seem to live ripe old ages, so, you know, astronomy and science is good for you. There's proof. There you go. Anyway, Edmund Halley, he was an astronomer and physicist. He later on became, I think it was the second Astronomer Royal. I know he was after Flamsteed, but these are all names that you know about, aren't they? You might not know where they fit into this stuff. But anyway, I mean, we all know where you've heard Halley from, and it's Halley's Comet. But anyway, that's what I'm going to talk about. Halley was a really keen lunar observer. He loved the moon. But he was also interested in the problems of gravity, and specifically how he could, or anybody could, prove Kepler's laws of planetary motion. Right? This is the thing talking about a planet's orbit and speed, depending upon how close it was to the sun and stuff like that. Anyway, Halley, I think, did know Newton beforehand, but in 1684, Halley visited Cambridge, and what he discovered, and a lot of people were scratching their head about this, what he discovered, that Newton had already solved this problem of gravity, but because of certain academic infighting, shall we say, and there's some great stories in history about this stuff that if you haven't looked at it, look at Isaac Newton, Robert Hooke, all of that kind of stuff. It's really fascinating stuff. We have still got some fantastic images on the homepage of Comets. I'm sorry, people who have been watching our shows know that I get a little bit distracted when I see gorgeous images, and in all three telescopes we have got some wonderful images of comets. In the T2 wide field we've got a comet just right of center, and then you can see a galaxy just to the north around the 1 o'clock position. T2 high mag is showing this comet beautifully. Let me just check which one is that. That's time is 23. That is McNaught, I believe. Anyway, back to my story before you all fall asleep. Wake up. So, Halley visits Newton in 1684 to try and find a way of solving this problem, finds out that Newton's already solved it. And in fact, I think Halley was the person who persuaded Newton to publish those laws in, I think it was Newton's first book, wasn't it, Principia or something like that. And Halley actually paid for that to be published, so he really wanted it out there. But anyway, what they discussed was the application of those theories and laws, and how they could apply that to predicting the return of one of these comets, because they'd both seen this previous comet in 1681. Halley went away, and what he did was he gathered up all of the observations of comets from every source, every historical source that he could find, and he started to catalogue them. Now, I think a lot of you know that a lot of science is about searching for and finding patterns in data. It says a lot usually. It gives you a direction to follow, and that's what he found. He found 3 observations in particular, which gave an almost identical description of a comet. And we've seen tonight from these images we're seeing tonight, they all look different. They all have their own character. You know, I guarantee that if I showed you a lineup tomorrow night, you'd be able to pick out Comet Hergenrother quite easily from a kind of, what do the police call them, you know, ID parade or something like that. So anyway, he found these 3 observations that look very similar, but not only that, there was an added part of the pattern. Each of those observations occurred at 75-year intervals: 1531, 1607, and 1682. Sorry, mental maths not good at this time of night. Halley actually went on, cut a long story short, because I am overrunning now. Halley went on to make a public prediction of this comet's return, and that was going to be at either the end of 1758 or the beginning of 1759. Now, the great pity and shame about all of this is that neither Halley or Newton lived to witness the return of the comet, because it did return. It was Halley's comet, and it returned on Boxing Day 1758, just at the time when Halley, using Newton's laws of gravity, predicted that this comet was going to return. So that was a bit of a game changer as well, don't forget, because that was the first time that, you know, a body had been predicted in that kind of way. Now, after that, what was interesting, what I found interesting when I was reading up about this stuff, is that astronomers after that time, so don't forget Halley and Newton are dead, but they see the comet return. But now that's been proven very clearly to them, not in retrospect, but it was a future prediction. Other astronomers kind of picked up the baton, and they reviewed even older observations and records and documents, and what they found that Halley's comet had been observed and recorded before. The first record they found of it was 164 BC, and I think that was the Babylonians who saw it. And then I spoke right at the beginning of the show, Genghis Khan. Which comet do you reckon it was that he saw? It turned out to be Halley's comet. And finally, the one that we all know, Bayeux Tapestry, ring any bells? William the Conqueror, all that kind of stuff, 1066 in the UK. So I think the return of Halley's comet then would have been 1068, wouldn't it? Anyway, there we go. We last saw Halley's comet in 1986, and that was a big sea change as well for us to understand comets. Because of this coma, images, by the way, have gone off comets, and they're now on normal Slooh members missions. So this is what Slooh members are looking at. It's still a comet on the half meter if you want to click through to that. The Europeans sent out the Giotto spacecraft, and it visited Halley's comet, and it flew to so close, it was 370 miles away, and it was the first time that a comet nucleus had ever been imaged, photographed, because usually the coma, this kind of ball of gas and dust surrounding and building up over the comet's surface, it obscures the nucleus, and the nucleus is really usually quite small inside it. By the way, Giotto, he was an Italian Renaissance painter, and he apparently observed Halley's comet in 1301, and he put it in his painting Adoration of the Magi, and he actually put Halley's comet in as the Star of Bethlehem, and that's why they named the spacecraft Giotto. Anyway, so it's a useless fact for everybody there. And I'm sure a lot of us will be hoping that we're here in 2061 when it returns, if I've got my dates right. Some of us may be more hopeful than others on that. How long is that away? Yeah, okay, I'm hopeful. Maybe, there's a good possibility. Anyway, I'm well and truly running out of time. Fourth dimension catching up with us again. Oh, by the way, I did mean to say, it's a bit of a depressing note to finish on, but I said at the beginning that you'd think that all we now know and understand about comets, that the mysticism would disappear about them, but unfortunately not. In 1997, there was a beautiful comet called Hale-Bopp, appeared very bright, and you may or may not know about this, but there was a cult in California, named Heaven's Gate, and they believed very firmly that there was an alien spacecraft inside the comet. And to release their souls so that they could be transported to the spaceship, 39 members of that cult committed suicide. So even now, when we understand so much about all of this, there's still a huge body of people who prefer to believe in mysticism and other things. I'm just going to switch my views over because the images on the homepage have now stopped. And I think, although that might sound a bit depressing at the end of this show, you know, it's the reason why we should do more of this. We need to redress this kind of hokum thinking, these kind of beliefs that have no founding. And the only way we can do that is not to argue, because arguments never work in that, but all we can do is try and present factual information, hopefully in the same way that these month live astronomy shows have been doing, you know, for the last 30 days. And we just got to chip away. We've got to chip away with the truth, I think. I love doing it. Slooh loves helping me do it, but Slooh also needs your help to do it as well. So please, if you can, support the campaign at slooh.com/mysky, or take up a Slooh membership. You can control the telescopes that we were using tonight to image these comets and stuff like that. You control them. Go back in the Slooh on Air YouTube library, and you see I put a couple of videos on there exactly how people use Slooh and stuff like that. But they're being used now. Slooh members, I haven't looked up what they're looking at, but anyway, I've got to let you know what we've got coming up, because we've got some really exciting stuff coming up. Tomorrow night is the Delayed Crab Nebula show. That's the supernova remnant. And that's going to be a really interesting show, I think, because I'm going to look at that in a slightly different way. I'm not going to really talk so much about supernovas, but I'm going to talk about how that object that we see in the night sky, and we will see live tomorrow night, how it became like that. How did it start off? And that one, of course, started off in 1054. And in 1054, Chinese and Arabian astronomers witnessed a supernova so bright that it was visible in the day. And we now know, and you'll find out tomorrow night if you watch the live images and watch the show tomorrow night, we'll find out how it got from that to this beautiful object that we're going to see tomorrow night. Monday night, wow, really busy night. I have for you more Jupiter phenomenon than you could shake a stick at. We've got, I think, great red spot transits, shadow transits, all sorts of stuff. Also got another potentially hazardous asteroid for us, and I'm going to use that. I said on the show the other night when we showed 2 asteroids which weren't potentially hazardous asteroids, but I said on the show the other night, I've got to stop rolling my eyes up, you want to see the whites of my eyes, that I'm going to talk about the classifications, because it's quite complicated and it's quite confused, all of the classifications of NEOs and NECs and PHAs and all manner of those things. I'm going to try and clear away, because I want to clear away, you know. And I was sitting there the other night thinking, look, if this is confusing me, goodness knows, well, actually maybe it is just me, maybe you lot know all about it, but if you don't, come and join me on the Monday night show as well. That's about it for tonight. So I hope you enjoyed those live views of comets. I'm going to go and check some of the images, see if we did catch any really faint ones right at that, I think, that second lot. But we saw some pretty nice comets there live. The clouds didn't get in the way, which is pretty cool. I'm Paul Cox. This has been Slooh Space Camera. Join me tomorrow night and every night, probably until the 10th of October, certainly. So I look forward to seeing you tomorrow night. Good night. Clear skies.